Welcome to a video on using a TI-84 online calculator to find probability in a normal distribution. Let's consider the problem. A college has a practice of replacing faculty desktop computers every few years with an average of 6 years and a standard deviation of 1.5 years. Using a standard normal distribution, estimate the probability that faculty member's desktop computer will be replaced between 9 and 10.5 years. Let's begin by looking at the TI-84 key sequence. First, you have to use the second key, then the distribution and the normal CDF in that distribution, the lower limit of 9, an upper of 10.5, mean of 6, a standard deviation of 1.5. So the key sequence is the second function key, then distribution, then the normal CDF, which is the second option here. We can punch the number 2. It will automatically select that. The lower is 9. It's already entered. We enter that. Then 10.5. I'll enter that again. Then enter that. Then 6. Enter. 1.5. Enter. And then paste. Now to calculate, you have to enter one more time at this point. And again, check it out. It's going from 9 to 10.5 with a mean of 6 and a standard deviation of 1.5. We hit enter. So here's our probability, 0.0214, that the value would be randomly selected between 9 and 10.5. Of course, to change that to a percent, you'd write that as 2.14% approximately, or 2.1 if you round it to the nearest tenth of a percent. If you use an online calculator, in my class, I usually have these quick links, and it usually just tells you an online calculator link. This is the URL. If you're not in my class and you're watching this video and you don't have a quick link, that's the URL that you'll use. You can take a picture of that if you need to. I'm going to go to this link now. It's taking a minute to upload, it looks like. And so on this, I'll make it a little smaller so I can see everything. As soon as you highlight distributions, you'll have an option of we're using a normal distribution. This is kind of the default picture you get. We're looking for values between 2 points, that is an x value. What's the probability that some randomly selected value would be between 9 and 10.5? So this is already highlighted. If you wanted just less than a certain value, it would go all the way to negative infinity here. If you wanted more than a value, it would go all the way to positive infinity. So this is we're selecting this one, which is in between. Our mean is known to be 6. The standard deviation we know is 1.5. And then we have to click Update. And the A value on the left, that would be 9. And on the right is 10.5. And then we'll just hit Calculate. And you can see we get the same area, which is our probability, out of 1.0214, which is 2.14%. And I like this online calculator because it gives you a picture. You kind of can verify, yes, that looks correct. Our mean is 6. And as you can see, back in the original, this was the mean. Notice it gives you the z-score. 1 standard deviation is 7.5, 2 is 9, and 3 is 10.5. So this is really between the second and third standard deviations from the mean, or z-scores. So there's our solution. Again, 2.14%. Same thing we got with the TI-84. Now, if you use the empirical rule, you would have to translate that 6, and the 6 being the mean and 1.5 being the standard deviation. And then between 9 and 10, you'd see that 9 falls 2 standard deviations to the right. 10.5 is 3 standard deviations to the right. And using the empirical rule, that estimate, which is not as good, is not as accurate as the online calculator or the TI-84, it's 2.35%. In problems on my class, that would be counted as an error if it's asking you to use the TI-84 or to use an online calculator. If it doesn't say use the empirical rule, this will not be given credit. So you can see that it's different than the actual solution of 2.14. So using the standard normal distribution calculator, we get this. If you use the empirical rule, you'll get 2.35%, which is not, it's a reasonable estimate, but just so you know that you need to use the calculator, make sure that you do that, because it'll give you a different answer, slightly different. Okay, I hope you found this video helpful.